This is lesson 27 for 8th grade, and today we're going to talk about the laws of exponents. And we've used these exponent rules before probably without realizing it, and we're going to kind of define those today and use them so that we can take some shortcuts later on. So here's our agenda basically. What we want to learn the laws of exponents and understand why we can use them, and then we're going to apply them to the problems that we have. At least the ones that deal with exponents. So we're just going to dive into that today. We're going to keep it pretty short. But we want to recall that a counting number indicates, or a counting number exponent indicates how many times a base is a factor. So that's basically saying if n was a counting number, that's telling us how many times we're going to multiply x. So it would be x times x times x times x, an n amount of times. If this was 3, it would be x times x times x. Okay, so it's whatever n is, that's how many times you multiply x together. Okay, so by applying this knowledge, we can begin to develop the laws of exponents that describe relationships between exponents for certain operations. And we're going to take a look, we're going to take a look at 3 different operations today, and this would be our first one here. So it says we want to find the missing exponent, and we're going to write the number of it in this box here. So it says x to the 5th power times x to the 3rd power. Well, we know that x to the 5th is x times x times x times x times x. 5 times, multiplying x together 5 times. And we're also multiplying it times an x to the 3rd. X times x times x. Alright, that's a little bit darker. There we go. Hopefully you can see that. I didn't realize it would be this dark. But anyway, at this point, we're multiplying 1x to times, so how many x's are we actually multiplying together when we look at this? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 x's being multiplied together. That means this should be x to the 8th power. Alright? Now we should notice that, what's the shortcut that we took here? X to the 5th times x to the 3rd was x to the 8th. Looks like we just added 5 and 3 together. Okay? That's a shortcut we can use. Now let's look at this one. Find the missing exponent when 3 to the 5th is divided by 3 to the 3rd. So we're going to fill this box in. Well, let's write out what we know. 3 to the 5th means 3 times 3 times 3 times 3 times 3 all over 3 times 3 times 3. Okay? So we have a bunch of 3's being multiplied on the top and a bunch of 3's being multiplied on the bottom, and we're dividing. That's what this bar means. So now we can do our little cross the out thing. Very technical term there. 3 and 3 can go, because 3 over 3 is just 1. Another 3 over 3, and another 3 over 3. And now we're out of things to cross out. We can do that because everything's being multiplied down here, and everything's being multiplied up there. Okay? Alright. So what do we have left? We have 3 times 3 over 1, basically. Or just 3 times 3. 3 times 3 is 9. But what we really have here is 3 to the 2nd power. There are 2 3's left. 3 times 3 is 3 to the 2nd. Alright. Now let's take a look at maybe the shortcut that we used for this one. So it looks like 5 minus 3 is 2. Alright. So maybe that's one of our shortcuts. So up here, when we multiplied, we had the same base, x and x. When we multiplied 2 things that have the same base, we could add our exponents. 5 plus 3 give us 8. When we were dividing with the same base, 3 and 3, 3 to the 5th over 3 to the third, we can subtract our exponents. 5 minus 3, and we got 2. That's our other shortcut we can use. And here's our last scenario. I'm going to, I'll put it down here. Alright, so once again, find the missing exponent. We have x to the third to the second power. Now remember, x to the, well, anything to the second power means we're going to multiply that thing together twice. So we've got, really, we have x to the third times x to the third. Or, if we write this out the extreme long way, we know that x to the third is x times x times x. Times x times x times x. So how many x's do we have there total? 1, 2, 3, 4, 5, 6. 6 of them all being multiplied together. This should be x to the 6th. Okay. Now, if we already remembered to use, okay, we had the same base, x to the third. We had x and x for the same base. So x to the third times x to the third. We could use this rule right here. We could have just added these two together. 3 plus 3, we got 6. But, what's the even shorter way? Well, looks like in this scenario, we could do 3 times 2 to get a 6. So, same base, x and x. We added our exponents when we multiplied. Same base, 3 and 3. We subtracted our exponents when we were dividing. And when we took basically a power to a power, we could multiply those two together to get x to the 6th power. So that's basically what we're saying here. And I'm going to show you this in generic form on the next slide. This would be a good thing to remember, maybe write it down or at least make a note of where it is in your book. So notice the shortcuts for each problem above. We already went through that. Here are the laws for our exponents, and this is for multiplication and division. So as long as your bases are the same, x and x, and we're multiplying, you can add your exponents. So whatever a and b would be, they could be numbers, they could be letters, it doesn't matter. Same base, when you're multiplying, x to the a plus b. A plus b right there. Probably not that easy to see. A plus b. Whenever we're dividing and we have the same base, so x and x over a divided by x over b, we do x to the a minus b. And that's as long as x does not equal 0, because remember, if you have 0, you can't have 0 in the denominator, because you can't divide by 0. So that's the only reason that's there. And for our last one here, a power to a power. So x to the a to the b power. These can be numbers, remember, don't worry about that. We just multiply those two together. So that's a times b. X to the a times b. That's our shortcut for those scenarios. So that's a good chart to have memorized. We'll be using those a lot in algebra. Alright, so real quickly, write each expression as a power of 10. That means we're going to leave these as 10 to the something power. So 10 and 10 for our bases, and we are multiplying. Remember, that means we can add. So this is 8 plus 6. Or 8 plus 6 is 14. 10 to the 14th for that one. Letter B, real quickly. Same bases, 10 and 10. 10 to the 8th over 10 to the 6th. This one we can subtract. 10 to the 8th minus 6. And it's always the top one minus the bottom one. Or, as we know this, 8 minus 6 is 2. 10 to the 2nd there. And I believe that's our last slide. Yes, it is. So we'll be talking about this some more, and that was your Laws of Exponents, lesson 27.